Good morning, everyone. We will start with data transmission, that is Block 1 Unit 2. Okay. So we will see the definition, that is what the data communication. As you can see in this figure, there is one sender and one receiver here. Okay. So what is actually communication? Communication from a source to a destination in our computer networking, that is from one computer to another or from one node to another, that is the communication. And in this communication, what actually we are transferring the data. Okay, so data communication means what? Transfer of data from one node or one machine to another, that is the message. Okay, and this is what the medium. Now we will see the, we have seen the protocol means the rules for transferring. Okay, so that is the rule set which is present in here in the sender as well as the receiver. Okay, so the transfer of data from one machine to another machine such that what the transformation should be meaningful. Okay, that the sender and the receiver both should interpret the data correctly. Okay, if you are transferring A from this to this and he is receiving X, then this is not the correct way. So the data should be what? Interpreted properly, correctly. Then that data communication is what? Meaningful. Okay. So this is the simple definition of data communication. Now, what are the different terms? Okay, what is channel? The channel refers to a path of communication between two computers or devices. Okay, that is the path. Now, next is the baud. What is that? It indicates the number of bits per second that are transmitted. Okay, number of bits. What is bits? Bits are what? 0, 1, that is the binary digits. And 300 baud means that 300 bits are transmitted each second. We have to solve the examples for what? Calculating the baud in the next units. Okay, so remember, this is what? Transferring bits, number of bits transmitted each second. Okay, that we are measuring in the terms of what? Bits are transferred in terms of seconds. So that is the baud. Channel is what? The path of communication between two computers or devices. Okay, that may be anything. We will see the what are the different channels in detail. Bandwidth. Okay, this term we are using in regular mode. What is what that bandwidth means what? The amount of data or signals that the transmission media can carry in a fixed amount of time. Okay, means the capacity. We can, in short, we can say it is the capacity. Then the frequency. Frequency is the number of cycles or periods a signal completes within 1 second. And as you know, we are measuring the frequency, like CPU frequency, we are measuring in terms of the unit is what? Hertz. Okay, so remember these terms: channel, baud, bandwidth, and frequency. Okay, we are measuring the frequency means what? What we are using what? Kilohertz, megahertz, that is 1000 hertz equal to 1 kilohertz. Then 1000 kilohertz is equal to 1 megahertz. Like this, we are measuring the frequency in terms of unit, that is the hertz. Okay. Now next is the very simple, how, what are the different modes of communication. Okay. See, these modes of communications are classified according to the three types. How, what is the way of transmission direction? according to direction, according to synchronization between devices, and according to number of bit traveling at the same time. That is what how these data communication modes are divided. Okay, so first is what, first we will see what is serial transmission and parallel transmission. Means what, we are transferring the data from source to destination, and that how we are classifying the modes according to how the number of bits traveling at the same time. Okay, so first is what, serial transmission, parallel transmission. Then next is the synchronization, that is divided into what, asynchronous, synchronous and isochronous. Okay, we will see the detailed definitions how it is worked in the next slides. Next, the way of transmission, simplex, half duplex, full duplex. Okay, how, what is the way of transmission direction? According to it, this data is, mode of data is what classified. So as you can see, the figures. Okay, in this I think in whole our data communication and networking, if you remember the figures, you can write down the definition properly or the note properly. Okay, so what is serial data transmission? You can see here the number of bits are there. Here is the receiver, sender is there, receiver is there. Okay, now how they are transferring bit by bit, one by one. First zero, then one, then zero, then like this. Means this is called as what? Serial transmission. Okay, serial transmission, bits are transmitted serially, one after the other. Means when zero bit is transmitted, then one, then zero, then zero. Okay, like this. As this is the simple figure where sender is transmitting this much of bits to this receiver, but this transmission is what, serially, means one after the other. Okay, the least significant bits, this is called as the LSB, is usually transmitted first. Okay, so first this bit will transfer, then this. Means what, it takes one bit is transferred at a time. Okay, when first is completed, then we will go to next, then we will go to next, like this. And what will the scenario at the destination? At the destination, all the bits are collected and measured and put together as bytes in the memory. Okay, so this is what the serial data transmission. Now, parallel data transmission. What we are seeing in the parallel data transmission, all the bits, okay, all the bits of a byte are transmitted simultaneously on separate wires. Okay, the transmission wires are separate. This is the difference. Here only one wire is there and we are transmitting one by one. Here the different wires are there and all the bits are transferred to the destination simultaneously. Okay, so what we require here, here we want the multiple connections. Okay, see, here is only one single connection. Here we require multiple connections, separate wires. Okay, and this is the fastest method of transmission of data. How it is fastest? Because of what? At the same time, we are transmitting 0 as well as 1 as well as 1. Next, all bits are transferring at the same time. So this is the fastest method. But as we require what? More connections. So it is expensive one. Okay, we require several wires for connecting the sender and receiver. So that is the parallel data transmission. Are you getting this? Sender, receiver, the medium, source, destination are same. Just here one single line is there, single source, single communication channel. Here the different wires, multiple connection channel. It is what somewhat time consuming. It is the fastest method. It is less expensive. It is more expensive. You can remember the terms in this form. Okay, we will see the next. So this is the comparison. Data flows in two directions, bit by bit. Okay, data flows in multiple direction, 8 bits at a time. All the bits are transferred at the same time. This we have already discussed. Economical, expensive. Pulse is 1 bit. Here is what? Number of bits transfer per clock pulse is 8 bits. Slower, faster. Used for long distance communication. Used for short distance communication. Why? Because if the distance is more, we will require more wires. So it will be more expensive. Computer to computer. This is also computer to computer. Next, we see the transmission mode according to synchronization between the devices. Okay, so what is synchronization? So we will see the synchronous communication first. So as in diagram we can see, this is the synchronous communication. In this type of communication, whole block of data bits is transferred at once instead of one character at a time. Bits in a synchronous data stream must be transferred in synchronization with a clock signal. Okay, clock signal means there is what 0, 1, 0, this type of signal is there. A synchronization signal which is used to tell the receiving station that a new frame is arriving and to synchronize the receiving station. Okay, means what? Here transmission begins at a predetermined regular time interval. Okay, when we want to transfer, there the signal is sent to the receiver. Okay, and then he will be ready to accept the data, and then only the data will be sent. Okay, the control signals for the data are derived from a clock signal. Synchronous data transfer systems usually have an error detection mechanism. If an error is detected, the data can be resent. We will see the error detection mechanism in the block 2. Okay, the data is proper or not. Okay, we are checking with the CRC algorithm, that is the cyclic redundancy check. This algorithm is used to check the error detection in the data. Okay, so and this synchronous transmission is used for high speed communication between the computers. This is the synchronous. Next, asynchronous. As we can see in the synchronous means what? We are controlling the data through the signals. Now asynchronous communication. Bits is in an asynchronous data stream can be transferred at random intervals, and the data rate of the stream is not required to be constant. Okay, this is not the case. Okay, we can transfer or not transfer, means the data stream rate of the stream, means there is no what compulsion that 20 MB, 40 MB at the same time. The data may vary from time to time. Okay. A synchronous system uses a start a bit to signal the beginning of a data transmission, and stop bit is there for what? For the ending of the data transmission. All this asynchronous synchronous transmission have what? An error detection mechanism. And if there is error, what will be the policy? The policy will be what? We will resend the same data. Okay, so what will be the role of the start bit? Start bit will do what? It signals the starting of frame. Now this is the frame, data frame. Okay, it signals the starting of frame and enables the receiving this device to synchronize itself with the message. And in between this, there are the data bits where the data is what? Sent across. Okay. Next, last is the stop bit, which gives the signal that end of the data frame. Okay. Here we are dividing the data into the number of frames. Okay. And this asynchronous communication sends the characters one at a time, framed by a start bit and a stop bit. Each frame begins with a start bit that enables the receiving device to adjust the timing of the transmitted signal. And the compulsion, there is no compulsion that the data rate should be same. We can remember with this theme that the data rate may be vary. Okay. Next is the isochronous communication. In this we are okay, start packet, there must be what? Okay, sorry, the figure is wrong here. It must be what? Stop packet. Okay, so it is in between. An isochronous data transfer system combines the feature of what? Means it is the hybrid communication technology which incorporates the feature of what? Asynchronous and synchronous data transfer system. Sends what? Block of data asynchronously. In other words, the data stream can be transferred at random intervals. Okay. Each transmission begins with a start packet. Once the start packet is transmitted, the data must be delivered with a guaranteed bandwidth. Okay. So what is this? This is what? Combination of what? Synchronous and asynchronous. In this, we are using the both hybrid communication to what? Overcome the failure, overcome the disadvantage of asynchronous and synchronous. Means what will be the its advantage? It will be what? Transferred communication with the high speed. Okay. So it must be start packet and stop packet. The figure is somewhat, there is one correction. So we are transferring the data, block of data asynchronously. In other words, the data stream can be transferred at random intervals. Each transmission begins with a start packet. Okay, once there is the signal start packet, the transmission is begins. It has what? High speed communication is there. So this is what about the isochronous transmission. Next, This is the simplex, half duplex and full duplex communication. What we are seeing in the diagram, C, A to B, A is the sender, B is the receiver. C, direction of data in simplex, direction of data in the half duplex, direction of data in the full duplex. Okay. Simplex, the simple configuration method. One of the Here only one device, one of the communicating device can send data. Okay. Here the direction of data. This is transmitting the data from A to B, and B, what will be the work of B? B will what? Only receive the data. Okay. The work from A to B. A will transmit and B will just receive the data. Here communication is only one directional, means the unidirectional, where one party is the transmitter and the other is the receiver. That is the simplex communication. Next is the half duplex. Okay, half duplex. What we can see, there is communication between two direction. Okay, so it is the two-way communication where what both devices can transmit the data, but the underlying condition, it is not at the same time. When one device sends the data, the other device must only receive it. And when B is sending the data, A must receive it. When A is sending the data, B must be receiving it. Okay. Thus, both sides takes the turns for sending and receiving the data. So that's why it is called as the half duplex communication. You can remember and you can write with the help of these full figures. Next is the full duplex communication. What is that? We are transmitting the data from A to B and B to A at the same time. Okay, means we can transmit the data in two directions simultaneously. So it is called as the full duplex communication. Okay, so here both the devices are capable of what? Sending as well as receiving the data at the same time. So it is called as what? Full duplex communication. Okay, you are getting it with the help of direction, or with the help of this figure we can write down. Next is the regular, our analog and digital transmission. I think we all know the signals are what in the waveforms. Here what into the digital means the 0 1 form. Electronic circuits are used here. What? Logical circuits, that is the logic circuits are used. Next, noise, analog signals are more likely to get affected. Okay, there is much more noise, or the signals are not clear. Here the signals are less affected, so less noise. Okay, data transmission is not of high quality due to this noise. Here it is of what? High quality. The analog signals waves may be like this and the digital like this. You can write the difference according to this table. This is what we are learning from the BSc or 12th. We can remember these things. Okay, so these are the simple ones. Then transmission impairments. What are they? Impairments means what? What happens when we are what? Transferring the data from one what sender to receiver or receiver to sender. Means there are some scope of what? For errors. Okay, due to the medium, there may be the sender is not ready or the receiver is not ready. So this all conditions means, or maybe the transmission media is not perfect. So these are all the condition which causes the transmission impairments. Okay. First is the attenuation. What is that? It is the loss of signal. Okay. Okay. Sorry. First is what? Loss of energy as the signal propagates outwards. That is the attenuation. Okay. This is what? Loss of energy or loss of signal within the distance. If the distance is short, then less attenuation. But if the distance is more, there may be chances of what? High attenuation. Means what? The receiver cannot detect the signal. Means loss of signal in general, you can remember. Like if we are what? Tuning the radio, sometimes we are not getting the perfect station. So the station frequency may be what? At the high attenuation. So we can't get that signal. Next is the distortion. We can say the delay distortion. How it is caused? It is caused by the fact that the signals of varying frequency travels at the different speeds along the medium. Medium is what? The transmission medium. We can see the different frequency can signal have the different frequency, and according to the frequency the speed may changes. So delay distortion is what? Caused by the fact that the signals of varying frequency travels at different speeds along with the medium. Next is the noise. This is our regular. We are what? Unwanted energy, unwanted data, which are what? Gathered together while sending the data from the transmitter to the receiver. Why this is noise is there? It is caused by the electrons in a wire, which we can't avoid. Okay, cross connection is there, cross talk is there while talking on the telephone, which what results in the noise. So we can remember this definition. These are the simple: loss of signals, loss of energy. Okay, distortion means what? Different, like your bike. Okay, according to speed we are using the, if the scooty is there, the speed is less. If the bike is there, speed is more. So according to the frequency, the speed is changes. So receiver cannot what? Collect the signal or that transmission properly. Noise, it is due to the wires, electrons in the wires, which are what? Or the cross connection, cross talk, which is what? Unavoidable. We can't avoid this, which is what? Transmission impairments. That is the everything is not perfect while transmission. And what are the factors? How impairment causes? We are divided into these three causes. Okay. So next is the transmission media and its characteristic. First is the magnetic medium. It is the common way, like your magnetic tape, floppy disks we are using for transmission between the computers. Magnetic tape or floppy or disk we are using for the transmission. Next is the twisted pair. Twisted pair cable is there. You can refer your books for the diagram. Okay, and then this is the oldest and the most common transmission medium, that is the twisted pair. Example is our telephone system. We are using the means that telephone, not mobile, telephone system. Next is the baseband coaxial cable, which it is commonly known as what? Cox. Okay. A coaxial cable consists of stiff copper wire as the core, surrounded by an insulating material, which is what a conductor. You can refer your book for the diagram, okay, and just remember the characteristics. Go through that. Uh, okay, that is what 2.6.3, I think, or 2.6 something, where you can get the characteristics. Then broadband coaxial cable and optical fiber. We are using optical fiber for most of the communication. Okay, fiber optics, you all know this fiber optics. You can draw the diagrams and you can what, write down the characteristic. This is what the simplest part of this transmission media and its characteristics. Next is the wireless transmission: radio wave, microwave, infrared. So radio wave we have seen, I think, in the packet switching. That is, the radio frequencies are there through which we are using the we are transmitting the data. Then the microwave, we are using the microwave transmission. We are using satellites for this transmission. Okay, we have seen this microwave transmission also as satellite transmission. We are connected by everything on this earth. So that is the microwave communication. And the infrared. Infrared communication means what? For the short range communication, like our the remote controls which are used in our TVs, VCR, we are using this infrared wireless communication. Okay, so radio wave we have discussed about this. Microwave, satellite, infrared means your remote control on the televisions. So that is the infrared communication. Next is the wireless LAN. LAN is what? Local area network. So what will be the feature? A wireless LAN uses wireless transmission medium. Anything we can choose for this. Used to have high prices, low data rates, occupational safety concerns, and licensing requirements. Okay, for using this, we must require the license. Problems should be have been addressed, means what? Communication medium, the if we are using wireless communication, the issues which are required, which causes between this, it should be addressed or what, solved properly. Popularity of wireless LANs has grown rapidly. Why? Because if we are using wired connection, the configuration is more, or the look of that structure, due to that wavy wires, it is not as good as the wireless LAN. So this is one of the point in our second unit. Okay, so we have, first unit and first block, second unit. We have covered all the important points. So we will start with the third unit of the block 1 in our next lecture. So for this, you must write out the difference between each communication medium, that is parallel, serial, asynchronous, synchronous, isochronous, simplex, half duplex, and full duplex. Write down the summarized points according to the definition diagram. Okay, then write down the characteristics of each media, transmission media. Okay, and just go through this, the theory which is given for the wireless transmission. So we will see the next chapter in the next lecture. Thank you.